I was asked to go over a couple of questions in 9.1 homework before we started doing 10 point whatever I'm on. So, the first one that I was asked to do is 9.1 number 2. 9.1 number 2. Now, my problem's not going to be exactly like yours, but it's going to be very similar. And this is one we did when y'all were kind of brain dead on me last time. It said, compute the critical value of Z alpha divided by 2 that corresponds to the 93% level of confidence. So, first thing we're going to do, 93% level of confidence. Level of confidence means it goes from something to something. So that means that that 93% is going to be the percentage that's shaded in the middle. That 0.93 is going to be the percentage that's shaded in the middle. So how am I going to get each tail? 1 minus 0.93. And then what am I going to do to that?
Divided by 2.
Divided by 2. So 1 minus 0.93 divided by 2. So the 0.07 represents both tails. Then we're going to divide it by 2, so 0.035 is going to be each tail. So this tail is 0.035, and this tail is 0.035. Okay? Now, because this has a Z in it, it says compute the Z. That's like we're finding the Z score. And for these, we always want to find the positive, so we want to do this Z score. So what you're trying to do is you're trying to find the positive Z. And they're really telling you to do alpha divided by 2 because you're taking that 93% confidence interval and then you're taking that and dividing it by 2. But we're really wanting to know this. So if we know the shade and we're trying to find the Z, what are we going to use in my calculator? Inverse norm. Okay? So I'm going to do inverse norm, area to the left, and then the mean and the standard deviation. So my area to the left is going to be everything to the left of that point. So how am I going to get my area to the left?
0.93 plus 0.035.
0.93 plus 0.035. So my area to the left is going to be the 0.93 plus the 0.035, which is 0.965. That is my area to the left. What is my mean and my standard deviation going to be?
0 and 1.
0 and 1, because it did not give it to me. So in my calculator, I am going to do second bars. I'm going to do inverse norm. I'm going to do 0.965, comma 0, comma 1, bless you. And that's where my answer's coming from. And they told me 2 decimal places. Yay? And this is 9.1 homework number 2. 9.1 homework number 2. All right, the next one is 9.1 homework number 3. They didn't get very far. This one's actually not that hard. The point estimate of population, that is your p-hat. But you, and we don't have, normally I tell you that the p-hat is going to be x over n, like 240 over 400 or whatever, but we don't have that. So the way that we're going to find our point estimate is you're going to do upper bound plus lower bound divided by 2. And your margin of error is upper bound minus lower bound divided by 2. So to get your point estimate, if you don't have your x and your n, you're going to add your upper and your lower bound and cut it in half. And then to get your margin of error, you do your upper bound minus your lower bound. And it's always the bigger number first when you're subtracting. So just to show you what I did, and I know we did one of these because Austin divided by 2 the wrong way. I don't know why I remember that. So it's 0.586 plus 0.894. Get your answer and then divide it by 2. So that's going to be how we get the population proportion. And then we're going to do 0.894 minus 0.586, get your answer and divide by 2. Oops, I got it too fast. That's where we're going to get the second one from. So that's your first answer, that's your second answer. Now, for part C, P hat equals X over N, which is what we talked about just a minute ago. We know what our P hat is. Our P hat is our population proportion, so our P hat is going to be 0.74. What are we looking for? What is our N? Our N is right here. Our N is 1,000. We're trying to find X. So what do we do to both sides to get X by itself? We multiply both sides by 1,000. That's where the 740 is coming from for there. So your point estimate, if you don't know the X over N, is going to be upper and lower bound added together divided by 2. Your margin of error is going to be upper bound minus lower bound divided by 2. And then you're going to use your P hat equals X over N. And you found your P hat, which is your point estimate. Now, the last one was a little bit harder. And remember, don't judge your exam on what your homework is. I kill you on the homework. Are you good on that one? Move. Okay. And just because it has these does not mean that you have to use them. I kept going, do I need to go to those? The point estimate for the population, okay, this time we asked 10, 12 adults. Do you pretty much think televisions are a necessity or a luxury? Out of the 10, 12, 516 indicated that televisions are a luxury that they could do without. So in this problem, what does the 516 and the 10, 12 represent? What is the 516? What letter?
X.
Your X. What is the 10, 12?
Oh,
Your N. So 516 out of 10, 12. So 516 is your X. So your X is 516. Your N is 10, 12. So your X is how many people answered the question the way you wanted. Your N is how many people in your sample. Now, this time it wants to know the population proportion, which is your P hat. How do we find P hat? X over N. So I did 516 divided by 1012 in my calculator, and it gave me 0.510. Let me just show you that I'm not lying. And I did have to round it. And rounding it, the 8 told the 9 to go up to a 10. Now, verify that the requirements of the constant interval about P are satisfied. Now, if this was an N problem, we would say N is greater than or equal to 30. But this is a P problem. So there's 2 formulas that we have to do for P. We have to do that N and the 0.05 times big N. And we have to do the N times P times 1 minus P is greater than or equal to 10. Remember? So because we're doing a P problem, the sample is stated to be a simple random sample. They stated that it was a simple random sample. They gave me lots of choices, but they stated that. The value of, now they gave me a lot of choices there. They gave me like N. They gave me N times P. But this is the only formula that was one of those two formulas that talked about satisfying the P. That was the only one of the two that matched the formulas. Now, to get that answer, I use the formula NP1 minus P. My P is right there. And my N is right there. So I did 1012 times 0.510 times 1 minus 0.510. That's what gave me that number right there. Now, in the formula, it says that this has to be what? Greater than or equal to 10. So I just chose the one that says greater than or equal to because that's what the formula says. And the other formula, so this is the first formula. The other formula says that N is less than or equal to 0.05 big N. So this says, the other formula says, well, what does little n mean? The sample size. And what does big N mean? The population. So it says that the sample size can be assumed to be less than or equal to 5% of the population size. So it's just making sure that you know that the sample size is the same thing as little n, and that the big N is the same thing as the population size. It's making sure that you know that both of those formulas are used as requirements to make sure of the P. That's part B. And I'll have these in the notes. Now, part C says construct a 95% confidence interval. Well, nowhere in here does it talk about standard deviation. It talks about the X and the N. It says that the X was 516. It says that the N was 1012. And now it wants us to do a confidence interval of 0.95. So I go to my calculator and I do stat test, and I go down to A, and I am doing 516, 1012, and I'm going to pull this over so that you will have it. And then when I hit calculate, I don't want to write through that though. That's where those two numbers are coming from. So that means I'm 95% confident. Now, is there a 95% chance, or are we 95% confident? That's the only two difference between those. We are 95% confident that it's going to fall between this and this. So we're 95% confident that it's going to fall between 47 and 54%. Now, the next question says, is it a possibility that more than 60% of adults in the country believe that TV is a luxury they could do without? Y'all, this is like when people are doing an election and we're going, they've already put on that the president has won and we hadn't even voted on this coast or on California. How do they know the president's won? What they did is they had this huge sample size of several 100,000 people, and they said because of the sample size and the margin of error, we are 99% confident that if the rest of the people voted in the United States, he's still going to win. So they had already done a confidence interval and said, we know no matter what happens, if everybody else votes for the other person, this person is still going to win. Let's pop the champagne. Okay? But in the last couple of elections, it was like 3 o'clock in the morning and we're still waiting who's going to win because it's super close, because it was like 50-50. It could go either way. So this is saying 60%. In order to win, they have to have 60%. Is 60% anywhere in between this confidence interval? No, it falls outside the confidence interval. So it says, is it a possibility that 60% that we're super confident? No. It is possible, but it's probably not going to happen because 0.6 does not contain in that confidence interval. So if my confidence interval had been between 0.7 and 0.9, then I can go ahead and pop the cork. I know they're going to win. I'm 70 to 90% confident that this person's going to win. Right now, I'm around 50-50. It may or may not happen. So I can't be super confident because 0.6 is not contained in my, and let me just erase right here so that you can read those words when you, it is not 0.6 or 60% is not between, let me make it clear right here, 60% is not between the 47.9% and the 54%. So it's not contained between my confidence interval. All right, Part E. Use the results of Part C to construct a 95% confidence interval for the population proportion of adults in the country who believe televisions are a necessity. So what we did are the ones that said they could do without it. So we want to do the ones that say it's a necessity. So let me take this. So these are the ones that said they could do without it. This is Part C. So we want to do like the knots. How do you do a knot? 1 minus. So we're going to do 1 minus the 0.479, and we're going to do 1 minus the 541. We're going to do the knots. So in my calculator, 0.479, 1 minus 0.541, maybe not. Calculator's frozen. I'll do it over here. 1 minus 0.541 is 0.459, and this is 0.521, and we always put it in ascending order from least to greatest. So that's why this one went first and this one went second. So either you're pregnant or you're not pregnant. Either you have a TV and you think you got to live with it, or you could do without it. Cool? Better when I explain it? All right, so 10.1. We're going to talk about, and we aren't doing that one. This section is actually super duper duper easy. This is hypothesis testing. Hypothesis is a statement regarding a characteristic of one or more population. Hypothesis testing. This is, it's easy.
Maybe because I just know this.
Yeah. Hypothesis testing. The testing is a procedure based on sample evidence and probability used to test a statement regarding a characteristic of one or more populations. So we're going to have a hypothesis and we're going to do hypothesis testing. And some of you who are in like a science class, you have hypothesis. You know, what are you going to talk about? What are you going to test? That's why when I was in college, I double majored in math and chemistry because they were a lot of the same things. Hypothesis and hypothesis testing. Hypothesis is just the statement, And then the testing is gonna be where we actually do a procedure to test. Scroll up just a little bit. There's two types of hypotheses. Hypotheses is the plural for hypothesis. You have the null hypothesis. That is when it's an equal problem. So if it has an equal, it's going to be a null hypothesis or an H with a little zero. We read it as H naught. Like if you ain't got not money, H naught. Zero, not. That means no change. It is assumed true until evidence indicates otherwise. You are assumed you are assumed innocent until proven otherwise. That's your hypothesis, null hypothesis, H naught. That's your first type of hypothesis. Your second type of hypothesis is the alternative hypothesis. That one can either be a less than, a greater than, or a not equal to. That is what we call H1. So we have H naught and we have H1. This is the one that we are trying to find evidence to support. So we're going to have an H naught and we're going to have an H1. Your H naught is always equal. Your H1 is either going to be a less than, a greater than, or a not equal to. The problem will let you know. And in this section, all we're going to do is practice writing H naughts and H1s. So an example of an H naught, the defendant is innocent. An H1, the defendant, so he is innocent until proven guilty. An H1 is we are trying to prove him guilty. So he is innocent until proven guilty. This is what we're trying to prove. The H1 is what we're trying to prove. We are trying to prove that he is guilty. We're trying to find evidence to support that he is guilty. All right.
Could you scroll up just a little bit?
Yep, tell me where you want me to stop.
Right there.
Okay? The population parameters that we need to know is that P is the proportion, mu is the mean, and then we got our standard deviation. So we've got our P for proportion, our mu is our mean, and sigma is our standard deviation. So they're just reminding you what those letters mean. We have a proportion, we have a mean, and we have a standard deviation. P, mu, and sigma. All right, there's three different ways to set up the H naught and the H1. Am I good? Three different ways to set up the H naught and the H1. Your H naught is always going to be equal. This is showing you an equal versus a not equal. So your H naught is always going to be equal. This is showing you that this one is not equal, which is going to give you a two-tailed test. So if you have an equal and a not equal, it's going to give you a two-tailed test. Equal and a not equal gives you a two-tailed test. Your H naught is always going to be your equal. Your H1 is going to determine the type of test. Okay, now we're going to have equal versus less than. And y'all, this reminds me, it's pointing to the left. See how that little arrow, if I drew that as an arrow, that is pointing to the left, which makes it a left tail test. So, your H naught is always equal. Not equal is a two-tailed test. If it's less than, it's pointing to the left, it's going to be a left-tailed test. And what do you think if it's pointing to the right?
Right.
Oh, y'all are so smart. So for this one, it's pointing to the right. So it's going to be a right tail test. So if it's greater than, it's pointing to the right, so it's going to be a right tail test. So for all of these, your H naught is going to be equal. We just have to figure out, is it going to be not equal, is it going to be less than, or is it going to be greater than? The not equal means it's a two-tailed test. Less than is a left tail test, and greater than is a right tail test. All right, last thing on this page. Two types of errors. Our example was H naught. Our defendant was innocent. H1, our defendant was guilty. Type 1 error is alpha. That little symbol, the Jesus symbol, Rachel? Our Jesus symbol is alpha. And this one is beta. So type 1 error is called alpha. It's a level of its significance. You reject the H naught when the H naught is true. For example, an innocent person is in jail. That's an error. We do not want innocent people in jail. The other type of error means mistakes. The other type of error is a beta error. It's not rejecting the H naught when H1 is true. For example, letting a guilty person go free. So these are two types of errors that we don't want to see. We don't want an innocent person in jail, and we don't want a guilty person out roaming the streets. So rejecting the H naught when the H naught is true, and not rejecting the H naught when H1 is true. All right, here shows you another example of the alpha and the beta. This is a false positive. You're telling a man he's pregnant. Okay? Here, you're telling this 9-month pregnant person that she's not pregnant. So both of those are going to be errors. One's an alpha error. You're telling somebody that he's pregnant, but he's not pregnant. And here, you're telling somebody she's not pregnant, but she is pregnant. Those are both two types of errors.
Hell of a tumor then.
I know, something's growing, watermelon or something. All right, now. The null and the alternative hypothesis are given to us. So they gave us the H naught and they gave us the H1. We need to tell whether it's a left tail, right tail, or two tail.